Alright, so we fully completed one example in class of looking at row percentages, expected counts, as well as doing the hypothesis test to see if there really was a relationship between our two variables or not. So this is another example going through the same type of information. We're going to start with something that maybe some of you might care a little bit more about, looking at something sports related. So looking at kind of March Madness. It's an important time of year, especially I've realized since I'm new to this area, because there's lots of local teams that have a tendency to make it, including NKU last year. So who do our NKU students root for? We only give them a few options here. So we had a random sample of 800 NKU students, and they asked to choose between rooting for the following: University of Kentucky, Louisville, or Cincinnati. In addition to that, we recorded what state the student was from. So let's talk about who the population is, do some old stuff here first as well. So we're looking at just NKU students. Right, we're wanting to see who they root for, but do you think location has anything to do with who you vote for, right? So geographic location probably impacts that, so we do have to be specific and say NKU students. So we're just interested in this group. And I can't spell right. Interested in NKU students. I also might look at, students at UC. That'd probably be very different as well, since I'm not including NKU as one of the options there. So what variables did we record on these students? We recorded who they root for of our three options that we have. Right, that's going to be categorical. And then we have what state they are from, which is also going to be categorical. Now we're going to calculate and interpret our row percentages. So first, remember, how do I actually get a row percentage? I'm going to take my number, for example, 40, and divide it by its row total. This number divided by its row total. This number divided by its row total. So I'm going to take 40 divided by our 400, and I'll get 10% for that. I'm going to take our 105, divide that by our 400 to get 26.25%, and then I'm going to take my 255 divided by the 400 to get 63.75%. And then again, remember your totals over here for each row will turn out to be 100%. I'll create my little chart here. But this will have to be 100%, and this will be 100%. So now, for Ohio, we're going to take each of our numbers here and divide by the 300 instead. So I'll take my 118 divided by the 300 to get my row total there, my row percentage there, which will be 39.33%. I'll take my 116 divided by my 300, which is 38.67%, and I'll take my 66 divided by my 300 to get 22%. And then finally, I'll do a very similar thing here with the other group, except for this time, my total is 100 that I'm working with. It's a little bit easier to do those calculations pretty easily. So now we've calculated the row percentages. Now we're going to interpret them. So, of our 400 NKU students from Kentucky, we found 10% root for UC, 26.25% rooted for Louisville, and 63.75% for UK. Now looking at those from Ohio, so our 300 NKU students from Ohio. We found 39.33% root for UC, 38.67% for Louisville, and 22% for UK. And then finally, of the 100 students from another state, we found 26% root for UC, 32% for Louisville, and 42% for UK. That is interpreting our row percentages. Now let's talk about making sure we understand how to calculate an expected count. So an expected count is just using totals. It uses a row total, a column total, and the overall total. Then the question is going to tell me which row and which column to look at. So my row, I'll look at those from Kentucky. My column, for those that root for Louisville. And the overall total is my total number of students sampled, which is 800. So I'm looking here. I'm going to use my row total of 400, my column total of 253, and my overall total of 800. So we get 126.5. Now to interpret it. So remember, the expected is assuming there's no relationship between them. So if where students are from has no impact on who they root for, we would expect to see $126.5 of our 400 students from Kentucky to root for Louisville. Again, that's assuming that where they are from would have no impact on who they root for. That's how many students we would expect from our 400 from Kentucky to root for Louisville. Now next, before we actually dive into doing the hypothesis test, we're looking at the graphs to see if there's a relationship at all just in the graphs that we have. And so for this, I do have the data set out on Blackboard as well, so it's the March Madness example there. So just going to kind of like save your data set. On the desktop or something like that, so you can find it. Here's what it looks like. So to get the pie charts that you're looking at, I went to the graph, pie charts with data. What I'm actually looking for is who they're rooting for, grouping by what state they're from. So again, this is the response variable, and then this is the explanatory variable. And just so I can kind of see them all side by side here, you can do that and kind of see who they rooted for. So it's kind of how we got the pie charts. So from looking at the pie charts, does it appear, first of all, that the pie charts are very different? So at least a couple of them appear to be pretty different, right? If I compare those from Kentucky to those from Ohio, there's definitely a pretty big difference there. If I start looking at it, so our pie charts appear to be different. So let's see, more than 60% of those from Kentucky root for UK, while only 22% of those from Ohio do. Also looking at that, so and only 10% of those from Kentucky root for UC. While 40% of those from Ohio do. So hopefully you agree that they do appear to be quite different. Now we're actually going to perform that test to see if they are related. We're going to use a 5% significance level. I do have all of our StatCrunch output here for us. But while we're in a video and you can watch it again, I'll show you how we got all of those numbers. So we're going to go to Stat, Tables, Contingency. Then I have to choose between if I have the data, which I do here because I have every individual student's record. The summary would just be having the contingency table itself. My row variable or my explanatory variable is what state they're from. My response variable is the team that they're rooting for. And then I clicked I wanted the row percent, the expected count, and our contributions to chi-squared, and hit compute. I just reorganize it a little bit here in our output. So here's where I'll be pulling all of our numbers from. Alright, so our first step when doing a hypothesis test, of course, is the hypotheses. Again, the alternative is generally easier to do first. So our response variable is who you root for. And our alternative is always that they're dependent. Our explanatory variable is here is where you're from. And then the null is the same idea with the word independent. So who you root for is independent of where you're from. Step 2 is always that decision rule, which is to reject the null and believe the alternative if our p-value is less than alpha, which was given to us in the problem of 5%. Right, our third step here is the conditions first. So first we need to check to see how our sampling method was done. Which doesn't seem to have any bias to it. And then we need our expected counts, which if I look at my output, so this little cell format gives us what each number in here is. So the third number down is going to be my expected count. So I want to check to see that all of these numbers are at least 5, which they are, and I'm just going to record those numbers so I know I looked at the right ones. So 92, 126 and a half, 181 and a half, 69, 94.88, 136.12, 23, 31.63, and 45.38. Those are all at least 5. So we're good. The other part here I need is my test statistic, which is also just given to us in the output. It's this value, that 139.08. But what's nice about this is it does also, in my output, give me my contributions to chi-square, that very last number. If I add up all of those numbers, will actually give me this value. So that actually happened to do that full formula that we looked at last time. I can actually see where it comes from in my output. So I take that 29.39, the 3.65, the 29.76, the 34.8, the 4.7, the 36.12, the 0.39, 0, and a quarter. And this is roughly going to give us about the same thing. When I did this math, I got 139.06. So then rounding, it gets you the same thing. So we did this by hand together. It's doing all of that formula for you. So it's kind of like each of those individual numbers is each of those cells that we did here. So that step is done. Our fourth step is our p-value, which we just get from StatCrunch now. So it's just part of our output. So it's less than 0.0001. So I go back to step 2. Is that less than 0.05? Yes, it is. So I will reject the null, and I will believe the alternative. So then I can finally say, with my alpha of 0.05, since we rejected, there is statistically significant evidence to support. Remember, the last part is our alternative hypothesis, but in words, which it already is. So there's evidence to support that who you root for is dependent on where you are from. It's probably not too shocking here. So again, there's a second example, fully worked, and we'll do another example in class together next time.